Question number 1. ABC are integers that are sides of an acute angle triangle. If AB is equal to 9, how many possible value or values of C exist? Well, if the product of A and B is 9, so the scenarios we can have is A is going to be 1, B is going to be 9, or we can have A being 3 and B being 3. So the two sides of the triangle is 1 and 9 or 3 and 3. So let's call it case 1, let's call it case 2. If this is the case 1, and if we talk about the third side, then we know that every side of a triangle is less than the sum of the other two sides and is greater than the difference of the other two. So that gives us C should be less than 10 and it should be greater than 8. So the only integral value of C that is possible is going to be 9. So we will have one triangle whose sides are going to be 1, 9, 9. Now we need to find out acute angle triangle. So this should be acute. Now in a triangle, if we take the largest side, right now here we have 9 and 9 both as the largest side. If the square of that largest side is less than the sum of the squares of the other two sides, then it's an acute triangle. Since this is true, so this is going to give us first acute triangle. Now the second scenario is when the two sides are 3 and 3. In that case, C is going to be less than the sum of the other two sides and it's going to be greater than the difference of the other two. So that means C should be greater than 0 and it should be less than 6. So the different values of C that we can take are 1, 2, 3, 4 and 5. Now the triangles that we will be getting is going to be 1, 3, 3, and the next triangle we will be getting would be 2, 3, 3. The next triangle is going to be 3, 3, 3. The next triangle is going to be 3, 3, 4. The next one is going to be 3, 3 and 5. So we don't have to check all of them since we know this is an equilateral triangle. So this is definitely going to be acute. If this is going to be acute, so the triangles before them are also going to be acute, right? So we have 1, 2, 3, 3 more triangles that are acute for sure. Let's check the remaining two. So in this case, 4 square and 3 square plus 3 square. So 4 square is 16 and 9 plus 9 is 18. This is less. So this is again an acute triangle. Let's look at 3, 3, 5 scenario. 5 is the largest side. The square of that is going to be not less than 3 square plus 3 square, right? Because 9 plus 9 is 18. 18 is not greater than 25. So this is not going to be acute triangle. So we get a total of 1, 2, 3, 4 and 5. So there are going to be 5 such triangles that will satisfy the conditions over here. So the answer is going to be 5.